All right, there's a couple different cases when you're solving log equations. One, you know it's a log equation if the x is inside the log somewhere. So notice here it says log base 2 of x squared. Since the x is in the log, this is definitely a log equation. On this one, it's log base 2 of 2 to the x power. And that is also a log equation, even though the x is in the exponent, because the x is somehow inside that log. But if you notice on the two where the x is in the base of this power here. Now, I'm not talking about the base of the log, the base of the power. Over here, the x is in the exponent of this power. So there's two definitely different cases here, and I'm going to treat each of them differently. All right, so let's write this one out. So log base 2 of x squared is 4. Now, these are not hard and fast rules. You can kind of use either of these cases the way I'm going to show you. You can use them kind of interchangeably. So, but this is how I would do it. So if the x is in this base here, I'm probably just going to go ahead and rewrite. Because some of you might look at this and say, well, let's use the power rule. Well, I don't think we need that on this one. I'm just going to rewrite it. So let's rewrite. And again, I'm going to do this heart-shaped, butt-shaped thing. Okay, now, so it's 2 to the 4th power is equal to all of this. It has to be all of that, not just the 2, not just the x. So 2 to the 4th is x squared. And then we had an exercise where we rewrote a lot of this stuff, so that should not be that difficult. All right, and then now notice we don't have a log anymore, and that's the whole purpose of rewriting a log equation, is that it gets rid of the log. So then we just go ahead and simplify it. So 2 to the 4th. So we have 2, 4, 8, 16. So this evaluates to 16, and then we end up with x squared. And then I'm going to take the square root of both sides, so I'm going to get x is plus or minus 4. All right, we also have to check these into the original. Now notice we should check both of these, but now where the x is, I'm going to put a parentheses. And notice that regardless if I put a 4 or negative 4 in here, it has to be squared there first. Because we should know that we can't take the log of a negative number. But if I sneak in a little 4 right in here, say, or a negative 4, it doesn't matter, and I square it, we're going to get a 16. So we would have log base 2 of 16 is equal to 4. And this is in fact true, because 2 to the 4th is 16. That means the 4 will work. And also, again, by just kind of plugging in that negative 4, we can show that that one works as well. So both of those work. All right, now notice in this one, the x is up in the exponent of this argument of the log here. So we're going to definitely solve this one a little differently. All right, now this one, if the x is up in the denominator, or sorry, up in the exponent, that one we're going to use power rule. By power rule, we can multiply that. We're going to bring that right out in front and say x log base 2 of 2 is equal to 4. All right. Now, the issue is here that we still have a log, because over here I said, look, we don't have a log. But there's not an x stuck in a log, and that's the thing. We got the x out of the log. The x is no longer in that log, and we should be able to solve this. Now, since we know it's x times log base 2 of 2, there's like a little multiplication there that we don't have to write. And log base 2 of 2 is just a number, and we're going to divide that away. Log base 2 of 2, divide this side by log base 2 of 2. Okay, these cancel, leaving x on this side. And we get 4 divided by log base 2 of 2. Now, if you've noticed before this step, you can certainly simplify this. But we should know what log base 2 of 2 is. Right? Log base 2 of 2. 2 to what power is 2? Well, that's just a 1. So we can replace log base 2 of 2 with a 1, and we're going to get 4 over 1, which is just 4. And we just happen to get a 4 in this one as well. Okay, as a quick check, which we should always do on these. So I'm going to plug in the 4 right where that is. So log base 2 of 2 to the 4th is 4. Right? And again, 2 to the 4th, we know from, let's see, 2, 4, 8, 16. From over here, actually, that part of it, we would have log base 2 of 16 is equal to 4. And again, it's kind of the same as over there, and we know that to be true. So that tells us that this x equals 4 is correct as well. All right, so let's use some of these cases and take a look at how we should solve these. All right, so looking at this one, it says log base 3 of x plus 1. Notice there's no power to this. So I can't use a power rule. I can't bring this x plus 1 out in front. It would have to be something to some power. And it's just a 1 here. And you can bring a 1 out, but that doesn't do anything. All right, so this one tells us pretty much that we have to just rewrite this. Okay, so I'm going to go 3 squared is x plus 1. Right, like that. 3 squared is x plus 1. It's just rewriting it. All right, and that's it. So, and we just have to solve for x. I mean, that's not it, but that's it as far as rewriting it. And then 3 squared. Well, we know that's 9. We have x plus 1. Subtracting 1 from both sides, and x is 8. Now, for some of these, I'm just going to do a quick inspection and make sure this works. So up here, if I plug an 8 in right here, so 8 plus 1 is 9, and we know that 3 squared is 9, so that one works. So there's an answer. All right, number 2. So log base 2 of 2 to the x plus 1. Well, this x plus 1 right here is up in the exponent. Okay, if we think about this being log, right? Log base 2 of 2, and I'm just drawing a little dashed line here. It's 2 to the x plus 1. This is the exponent, so we have to bring that out in front. So I'm going to write x plus 1, parentheses, of log base 2 of 2 is equal to 3. All right, we can, if we want, go ahead and distribute this to the x and to the 1. So we're going to get x log base 2 of 2 plus 1 times log base 2 of 2, which is just log base 2 of 2, is equal to 3. All right. Now, I know there's a quick, easy shortcut I could do on this, and I'm just not going to do it, just because. Just so you're used to working with logs, but this log does reduce. I just don't want to do it. So I'm going to subtract this log base 2 of 2 from both sides. Okay, so that gives me x log base 2 of 2 is equal to 3 minus log base 2 of 2. And then again, just dividing by this log on both sides completely. Okay, and this cancels that, and we get this right here. All right, now, both of these log base 2 of 2's is just a 1, right? Because log base 2 of 2 is 1. We have on the top, it's 3 minus 1 over 1. And that actually gives us 8/2. And if you were to check that up here, we would get a good answer. So we do have x equals 2. Please get in the habit of checking these. Not all of these work. I'm just telling you right now. Some of these I designed so they work out nicely. And not all of these work out. You will get extraneous solutions. Okay, this one. Well, you can't rewrite anything until you get to log by itself. Just like a radical equation, you have to get the radical by itself. So we have to get this log base 4 of x by itself. So first we're going to add 1 to both sides. We're going to add 1 here, add 1 here. So then I get 2 log base 4 of x is equal to 2 plus 1 is 3. Right? And then we got to divide this by 2, both sides. So we get log base 4 of x is equal to 3 halves. And then now that I have the log by itself, now I can rewrite this. So, right, and there's no exponent here, so I'm going to rewrite this. So I have 4 to the 3 halves power is equal to x. So 4 to the 3 halves power is equal to x. Well, now we have to evaluate this. So off to the side here, let's evaluate 4 to the 3 halves power. Well, that's going to be the square root of 4 cubed. So the square root of 4 is 2, and 2 cubed is 8. So the answer to this is x equals 8. All right, next one. Notice that the x minus 3 is up in the exponent. So again, we're going to use power rule. We have to bring that out because the x is up there. It is not right directly in the argument of the log. It's 2 to the x minus 3 power, so we're going to bring that x minus 3 out in front. We try to fit all this in. X minus 3 times log of 2. Now the difference with this one is we can't do anything with that log of 2. That's why I kind of carried this one around. Even though I knew early right here, I could do something with that log base 2 of 2. And you can as well. If you wanted to do this one quicker, you can make this a 1 right here, and this problem would actually be a lot quicker. But right here, we're stuck with the log base 2, and I can't simplify that at all. So we're going to carry that all the way through. All right, then with the power rule then done, we're going to distribute. We have to distribute the log base or log of 2 to the x. So we have x log of 2 minus 3 log of 2 is equal to 3. Okay, and again, we have to solve for x. So we get rid of the addition and subtraction first. So I'm going to add 3 log 2 to both sides. Just to save some room, I'm not going to show that work. So I'm going to leave x log of 2. Since I added 3 log of 2 to this side, that one disappears. And on the other, it appears as 3 plus, I forgot the 3. 1 second. Three plus, because there's a 3 right in front here, 3 log of 2. All right, now again, I forgot this 2 right here. All right. Because we need something after the log, or it wouldn't make sense. All right, now we're solving for log. So this one, I'll show the work. We need to get rid of this log of 2, so we divide it just over here, like we did over here with the log base 2 of 2. We're going to divide away log of 2 on both sides completely. Log of 2. All right, and this cancels, and we're basically done. There's nothing on the right there that we can really simplify, so we just have to leave it. And that's it. That's the exact answer. Now we can put this in the calculator, but I didn't really show you how to do all these yet. It takes lots of parentheses to solve that. And with that done, it's very difficult to check without a calculator. So as far as that goes, let's just trust we got the answer and we'll move on from there. All right, here's the product rule. So I don't want to spend a whole lot of time getting into why this works. I can do this in class. But so the product rule with exponent says that if you have a product that you add. So here's the adding. And the quotient rule says if you have a quotient, there's subtraction involved. So that's just like the exponent rules. So let's just follow the rules. Let's walk through the problem and let's just use it. So if we have log base b of x plus log base b of y, it turns into 1 log with multiplication. So let's do that. So we have log base 2 of 2 plus log base 2 of 8. So this will turn into 1 log with multiplication. So it'll have a 2 and an 8, but those two things will be multiplied together, not added anymore. Okay, oh, and it's log base 2. Okay, and then we can simplify that. So it's log base 2 of 2 times 8 is 16. And then we evaluate this. So 2 to what power is 16? And we know that answer is 4. Because 2 times 2 times 2 times 2 is 16. Now, this is not always going to be true, but I want to show you something else we could have done just to prove that we were right. And I made this problem very easy just so we could show that this is right, because it's going to work out. We can't really show it down on this one because there's x's involved. But you should know, let's take a look at this. What's log base 2 of 2? Well, 2 to what power is 2? Well, that's a 1 plus log base 2 of 8. Well, 2 to what power is 8? That answer is a 3. So 1 plus 3 is 4, which equals what we have over here. So I'm just kind of checking our work. I know we could have done this, but again, I'm just trying to show you an example of how the rule works and that it does in fact work regardless of what method that you use. All right, let's do the same thing on this one. And again, it's a very similar thing that happens. So if we have log of 10 plus log of 1,000, that will turn into 1 log. It will turn into log of 10 times 1,000. Very similar to what we just did above. And that will then simplify to log of 10 times 1,000, which is 10,000. Okay, and then we can just answer that. 10 to what power is 10,000? Remember, when you just see a log, it's base 10. So 10 to what power is 10,000? And again, the answer is a 4 on that one. Okay, this one here. Now, there's not much to do on this one. We're just going to put it together. So if you see 2 logs separated by an addition sign, you just make it 1 log and you turn it into multiplication. So we're going to multiply x to x plus 1. That's it. So it's natural log of x plus natural log of x plus 1 turns into 1 log, the natural log of x times x plus 1. Okay, you just combine it. You just smash it together using multiplication. Okay, subtraction is very similar, except with subtraction we have division, because that's why it's called the quotient rule. Okay, so when you see 2 logs separated by a subtraction sign, you can put it into 1 log, but now, instead of using multiplication, we're going to use division, and we're going to indicate that with a fraction bar. So it's the first one, 8 minus 2. So the top one is the 8. The 2 is on the bottom. Okay, now we can simplify this. So we have log base 2, and 8 divided by 2 is 4. And then we should know log base 2 of 4 is a 2, because 2 squared is 4. So this simplifies to 2. And again, just kind of proving this rule, log base 2 of 8 is a 3, and log base 2 of 2 is a 1, and 3 minus 1 is in fact 2. So this is just a check that our rule worked. All right, this number 2 here, using the same process, we have log of 1,000 minus log of 10. That will turn into 1,000 log of 1,000, all right, over 10, which is log of 100, because 1,000 divided by 10 is 100. And then you answer the question, 10 to what power is 100? And you answer 2. That's our answer. Okay, this one. Again, with some x's, very similar to this one. We won't be able to get a number answer to this, but we're just going to combine it. And you'll see why we have to do that on the next page here. So this will be log base 2 of the first one, which is x. Subtraction turns into division. And we have x plus 1 on the bottom. Okay, there you go. Use these rules. You'll see why we're going to use it in the next slide here. All right, well, we have some logs here. And notice one of our logs has an x inside the log here. So at some point, we're going to have to do some rewriting, but we can't do that yet because of this little guy over here. So I'm going to try to take these logs and I'm going to combine them. So since I see an addition, that means I can change both of these logs again into one log. Now we have some more room on this page here, so I'll write a little bit more work here. So this turns into log base 2 of the first number, x, times the 5, and that will be equal to 3. Now I don't like this x times 5, so I'm just going to rewrite it as 5x is equal to 3. Okay, now I took those two logs, I combined it into one. Now I can rewrite. So this is just a rewriting we did. And I'm rewriting here because this x is not up in the exponent. If the x were up here in the exponent to the 5, I would rewrite it. But you can't rewrite anything. Or sorry, I would use the power rule. But this one we're rewriting. So it's 2 cubed is equal to 5x. All right, use this little thing. All right, let's simplify that. So 2 cubed is 8. And that's equal to 5x. And then solving for x means we just divide both sides by 5. And we're done. That's it. You don't have to write it. This is a decimal. You just leave it as 8/5. 8/5 does not reduce. All right, let's just check on something up top. Okay, I think that one worked. Okay, this one, we have subtraction. So again, 2 logs. I don't like the 2 logs. I'm going to turn it into 1 log. And so this one makes it log of x divided by 2 is equal to 1. Now, a very important thing here, some students will try to write log of x divided by log of 2. Notice we took 2 logs, right? There are 2 logs up here. There's 2 logs. Down here, I don't know why. All right, something funky just happened there. So notice there's 2 logs up here. There's 2 logs up here. A little more to erase here. And here I only have 1 log. A very common thing would be to write log of x divided by log of 2, but we're taking 2 logs and turning it into 1. Okay, now we're ready to rewrite. Okay, this x is not up in an exponent. Okay, there would be an exponent here of an x if we could use power rule. Again, we're just rewriting. Okay, now in this one, since it just says log, this is log base 10, so I'm just going to sneak a 10 in right here so you see it, even though I do not like writing that 10. And now we're going to rewrite this. So it's that 10, right, that 10 there, to the first power is going to be x divided by 2. So 10 to the first power is x divided by 2. All right, and 10 to the first power is just 10. That's easy enough. We simplify that. And these always won't be, 10 to the first. You might have to simplify that a little bit more than we just did. And you just do that, and then you just solve the equation. So since it's x divided by 2, we're going to multiply both sides by 2. And we get 20 is equal to x. Okay. Okay. And I kind of did a quick check in my head up top there, and it does work. All right, 2 more slides here. This one here, number 5, is actually going to be fairly easy. All right, so on the left here, I have 2 logs, so I'm going to combine it into 1 log. So I'm going to write log base 3 of x plus 1 times x. And I'm just going to write the x right here. So 2 logs turned it into 1, addition turned into multiplication, is equal to log base 3 of 12. Okay. Now, the good news here is that I have 2 logs. When you have 2 logs and they're the same base on both sides, log base 3 here, log base 3 here, those two logs are going to cancel. It's kind of like I'm unlogging both sides. So I'm going to get rid of the log here, get rid of log on the other side. We can't do that up here unless you have one log on the left and one log on the right. Okay? And then we just have what remains. So right here I have x plus 1. I'm just rewriting it because I like the x on the left. And that's going to be equal to 12. Okay, and then I'm going to solve this. So I'm simplifying the left side. So I have x squared plus x equals 12. Now this is a quadratic, so I'm taking everything to the left side. And I'm going to factor. So this turns into x plus 4, x minus 3 is equal to 0. So this is going to give me x equals negative 4 or x equals 3. Now, a quick check. I'm just going to do a quick check right here. If you check negative 4 right here, and you plug it in there, this side of the equation will say log base 3 of negative 4. And you can't take the log of a negative number, so that one is automatically out. And the other one, I believe, works. Let's see, we get a 4 there and a 3. And so I'm checking it. You also need to check these and prove to yourself that that one works. The x equals negative 4 does not work because it will cause a negative inside the log, which is bad. Okay? Double check those. Do not circle anything that does not work. Okay, next one. Well, I have subtraction, so I'm going to take these two logs, turn it into one log, and since it's subtraction, I'm going to use division. So it's going to be x plus 1 divided by x minus 1 is equal to 2. So two logs separated by subtraction is going to turn into one log with division. Okay, so at this point again, I'm going to rewrite. So I have this 2 to that 2. So I'm going to write 2 squared is equal to all that stuff right there. So we get x plus 1 over x minus 1. Okay, I'm going to simplify this exponent right here. So we have 4 equal to x plus 1 over x minus 1. All right, now at this point, I have a rational equation. Now we dealt with rational equations. This is one of the reasons why we did it, because it shows up right here. So I'm going to multiply by the LCD. Well, the only LCD I have is an x minus 1. So I'm going to multiply both sides by x minus 1. All right, so this x minus 1 cancels that one, and that's why I multiplied by it to get rid of it. So this side is x plus 1, and this side will turn into 4x minus 4. All right, taking this x over here, I have 3x. Taking this 4 over there, it looks like I get a 5. And dividing both sides by 3, looks like I get 5/3. All right, that one was a little difficult to check, but I checked it, and I'm pretty sure that that one works. All right, last slide.